you through the derivative of exponential function and what I want to do right now. So how do we differentiate logarithmic function? So if you want to differentiate a logarithmic a function, okay, I need you to take note of the rule. So ds, give me 1 second. So ds, okay, ds, okay, for the sign if I want to differentiate the log this time around, not a natural log, right? So I want to differentiate the log probably to base a of x, okay, according to the law. So if I want to differentiate this guy, it's always going to be 1 over the x that is here, whatever that is here, then the natural log of a, okay? Now, if for instance, let's say you have DDS, at times you have DDS and you just have a log x, whenever you have a log x, it's assumed that it's to base 10, right? It's assumed that it's to base 10. So in that kind of situation, okay, you're actually gonna write 1 over s ln 10. Okay, 1 over x ln 10. So this is very, very crucial. Okay, whenever you want to differentiate log, okay, that's a special rule. Okay, now you're gonna see when I want to do this, how do I get this guy here? Okay, now if I want to differentiate this, I'm gonna use this rule number 1. Okay, here now a is 3. What is acting as x is 3x squared. Okay, now I said I'm gonna write 1 over x ln a, so I'm just gonna write 1, okay, over, okay, so whatever that you see here, right, is what you're gonna say 3x squared. Then the ln a, then you're gonna write ln 3. Okay, now then you're gonna block the log aspect and differentiate 3x squared, which is gonna be 6x. Because here, if you take a look at this guy here, okay, the reason why we got 1 at the top is because after writing 1 over x ln a, we still need to differentiate x. So differentiating x is 1. But in this case, differentiating 3x squared, okay, it's going to be 6x. So in the end, we now simplify. Okay, by the time you simplify right now, 3 goes in 6. Okay, that's going to be 2, right? And x here can reduce the 1 here, then I'm actually going to have this. So differentiating this now is going to give me that. Okay, that's how we differentiate our logarithmic function. Now I'm going to walk you through another example if you still want to follow the law. Okay, so if you take a look at here now, we're gonna make use of the law here. Okay, now the YDS, don't forget. Okay, now at the top, you can see 4s squared. We're gonna differentiate 4s squared, and that will be 8s. Okay, then divided by, don't forget, whatever you see here, 4s squared, we're gonna write it out. Then the ln 2. Okay, you can see now, that's super cool now. Or what I'm just going to do is to simplify, 4 goes in 8, x cancel that, then I have this as the final answer. So we're making use of the law. Okay. So if I really want to, let's say, I want to write a general law example, instead of putting hex there, okay, I'm actually gonna put something else. I'll give you 1 second. Let me go into another one so that you can see what I'm talking about. Okay, for instance, I want to work with this guy now. So if I want to rewrite the law, okay, I can say, okay, the law is DDS. So when you are given DDS, okay, of log, okay, of log A, okay, maybe I should write f of s, because it can be a whatever function, okay. Now what I'm trying to talk about now is going to be 1 divided by, okay, whatever whatever function that you see there, okay, whatever function that you see there, ln of a natural log of a, then multiply by f prime, okay, multiply by f prime of x, okay. That's what you're gonna do. So if you take a look at this guy now, this guy here is actually my f of s, right? Okay, it's actually my f of s. Okay, now that f of s, I'm actually gonna write it here if I want to solve that. So if I want to go by that particular rule right now, I'm actually gonna have 1 divided by 4s squared. Okay, don't forget 1 divided by 4s squared, which is the f of s here. Then I'm gonna write ln, what is a? My a is 2. Okay, now I need a differentiation now. I need to differentiate 4s squared, which is gonna be 8x. Okay, now all I need to do is just to simplify. So s cancel that. Finally gonna have 1 divided, let me see, 2. I'm gonna have, give me 1 second, um, because what's gonna happen, 4 is gonna go in 8, and the x here is actually gonna cancel that guy. So I'm actually gonna have 2, okay, divided by x, okay, ln 2, ln 2, okay. So this is so for number 4, we're actually gonna get 2 over s ln 2. So I'm gonna go to the answer key. Okay, that's why you see that 2 over s ln 2. So that was how I would get that. Okay, so I'm gonna go through another example right now. We're still on the log, right? Okay, so I think I'm gonna attempt one of these two. Okay, I think this guy is looking like more or less like this guy, so I can decide to choose any of that. Okay, now in choosing any of that, okay, don't forget about what the law says. Okay, don't forget what the law says. Don't forget what the law says. Okay, so the law says ds, okay, ds, okay, of a log, the log of f. Okay, f is a function. Okay, ds, okay, of log of s. Okay, so don't forget that that is going to be equal to f prime, f prime of s, okay, f prime of s, okay, divided by, okay, f of s, okay, f of s, okay, divided by f of s, okay, ln, okay, ln of a, provided the base here is that. So now, if you take a look at what I have here, so I want to differentiate this guy now. That would be super cool. Okay, so I'm just gonna, so I'm actually gonna say my dy ds at the end of the day, my dy ds, okay, my dy ds is going to be, okay, so differentiating that. So I want to differentiate this guy. Okay, you have to use the rule of composite function. Okay, so differentiating that guy. So I'm gonna have 5 coming down. Differentiate what you have inside it. That's gonna be 15 x raised to the power 4. Okay, 15 x raised to the power 4. Okay, then you're gonna rewrite everything. You're gonna write 3 x 3x5. Okay, plus 5. Okay, all raised to the power 4. Okay, now what I've done now is, is the f prime fs, that you have here. Now I want to do divided by, what is f of s? The whole of that. I'm actually gonna write it out. So 3 s raised to the power 5. Okay, plus 5 plus 5 plus 5. So raised to the power 5. Okay, I'm writing back the function now. And then lean, okay, of A. So your A in this case is 3, right? Now I just need to simplify. If you take a look at this guy here and this guy here, this is raised to power 4. Okay, this can cancel one of that. So if I simplify right now, I'm actually what is 15 times 5? I think 15 times 5, to the best of my knowledge, should be 75. So I'm gonna have 75 x raised to the power 4. Okay, 75 x raised to the power 4 divided by, I'm left with something there. Okay, so I'm gonna have 3x5. Okay, 3x5. Okay, plus so 3x5 plus 5. Okay, then the ln of 3. Okay, so that's gonna be the final answer. So this guy now is actually gonna be the final answer. So let's see what the answer key says about question 5. Now, that's exactly what we got. 75x4. We got ln 3 down below and 3s5 plus 5. So that was what we got. So that was what we got. You see that? That was what we got. Now, I'm actually going to solve one more question on the logarithmic. Give me 1 second. I think I'm going to solve the one that has to do with, trig. Okay. I'm going to solve, going to take one of these. If you take a look at these two here, you're actually gonna see this is an exponential function. This is a logarithmic function. Okay, so how do I differentiate this and how do I differentiate that? So I'm first gonna start with question 9 right now. So you're gonna see how we're gonna differentiate that. Okay, so right now, so you have, give me 1 second. You have this guy. Okay, there's no any log, right? So if there's no any log, what you're gonna do is to introduce ln to both sides, just like the way we've been doing it. So I'm actually gonna have ln of y, okay, equal. So the ln of y equal ln, introducing ln to both sides. Don't forget, whenever you want to undo exponential functions, so that's exactly what you're going to do. Okay, you're going to introduce ln to both sides. Okay, and the essence of introducing ln to both sides, because you want to bring the exponent down. Okay, so you want to bring it down. Now, after introducing ln to both sides, this is what I got. So what I'm gonna have now, so the whole of this guy is gonna come down, so that I'm actually gonna have ln of y, okay, I'm actually gonna have ln of y equal, okay, now what I brought down, okay, cos, I brought down cos cos 3 x raised to the power 4. That was what I brought down, right? Then that will be multiplied by the ln of 3, by ln 3. Okay, take a look at that. So I told you the essence of introducing ln to both sides is actually to bring the power down. Now I'm going to do something else. So differentiating ln y. So that's going to be 1 over y. Okay, ln of y. 1 over y, the ln of y, okay, equal, okay, I want to differentiate this guy now. So I'm going to focus on differentiating this guy now. So if you want to differentiate this guy, you don't forget you for differentiate what you have in front of this cos, which is going to be 12, okay, which is going to be 12 x raised to the power 3, okay. Now, when you have 12 x raised to the power 3, when you differentiate cos, what does that give you? So cos is going to be a negative sign. So I'm actually going to have negative sign, okay, or 3x raised to the power 4, okay, negative sign, 3x raised to the power 4. And finally, I'm actually going to put ln 3. And all what I'm going to be looking for now is what is my dy, what is you know, also differentiating in y supposed to be 1 over y, the y ds. Sorry about that. So 1 over y, okay, the y ds. That was a slip of tongue. So 1 over y, the y ds, I'm actually going to solve for the y ds right now. So in solving for my the y ds, okay, in solving for my dy ds, so it actually means I'm going to multiply the whole of this guy by y. And what is my y? You know, this is my y, right? So because of the negative that we have, so I can do negative, okay, for force write the y out, I'm actually going to get a very huge expression, okay, for force write that as my y, okay, that's my y. You know, the negative here is the one from here. So I can now write every other stuff like writing 12 or s cube, okay, writing 12 s cube, okay, or writing sine, or 3x4, okay, writing sine 3x4, and ln 3. You see that? You're going to have a very huge. The answer is going to be very huge. Take a look at that. It can be in so many forms. So if I go into question, I go to answer key in number 9 now. So you're gonna see, you see what we have, okay? You see 3 dot, ln 3, 2fx3, all of that, okay? So you see what I'm talking about, okay? So they can decide to like simplify further, okay? You know, the simplification here is just, okay, you know, if I actually leave my answer, give me 1 second, because there's several ways you can leave your answer. Okay, so I can decide to go further. Okay, like here now, I can decide to like, okay, break this 12 into 3 times 4, right? If I break it into 3 times 4, okay, if I break 12 into 3, okay, times 4, okay, so one of the 3 here. So I can combine this 3 with this 3, so that in the end, I can just say, okay, you know what, I got negative 3 raised to power, whatever that guy is. I can say cos 3 x4, okay, plus 1, because of the 3. Okay, so when I do that, don't forget I'm left with 4. So this guy is not going to be 12 anymore. So I'm actually going to have 4 x raised to the power 3. Okay, then I'm going to have sine. I'm going to have sine 3 x raised to the power 4. Okay, ln of 3. So I can also leave my answer in this way. Okay, I can leave my answer in this way. So there are several ways you can leave your answer. So whether you leave it in this way or you leave it in this way. So that is how to do that. Okay, so finally today, so I'm actually gonna walk us through another question, which is the one that involve a log. Okay, so and what you're gonna do is what we did the other time. If I want to solve this guy now, okay, so don't forget the formula, So I said if you want to do so that would be a DDS. Okay, you can write the formula how false. Okay, log, okay, log of A, okay, log for A, F of S, okay, F of S. So if you want to differentiate, okay, you want to differentiate something like that according to rule, okay, don't forget, okay, you're actually gonna have 1 divided by, okay, F of S, okay, F of S, okay, F of S, okay, ln of A, natural log of A right now, right? The ln of A, and here multiply by F prime of X, okay? So now what I'm going to do right now, since I know this is a formula, so what I'm actually going to do, my dy/ds now is going to be 1 divided by, so what is the f of s? So the f of s is actually tan, okay? It's actually tan, okay? It's actually tan 4, okay? X raised to the power 4, as you can see right now, okay? So that is my f of s. Then I'm actually going to do ln. Okay, ln of what? My A is going to be 5. You can see it's super cool, right? Then I want to differentiate now. I want to differentiate this guy. Now, in differentiating that guy, don't forget. So we're going to have 16. Okay, S cube. Okay. Now, differentiating tan is going to be a sec squared. So, sec squared. So it's going to be sec squared. Okay, sec squared for x raised to the power 4 right now. Take a look at that. So that's going to be my final answer. So if let me quickly show you in the answer key so that you'll be able to see what I talk about. You can see right now, I got that. Okay, so just simplify, and that's going to be your final answer. Is super cool. Okay, it's very, very easy to navigate. Okay, take a look at that. Okay, so make sure you all stay safe and have a lovely day. So bye for now, everyone.